All right, strap in, everyone. We're going deep, deep into these Google Cloud Professional Cloud Architect exam prep materials.
Yeah, yeah, the ones you sent over.
Exactly. So, our mission here, it's pretty simple, really. We want to help you absolutely crush that
We're
exam.
talking like walk in there and own it.
Own it, yes. And we're going way beyond just like summarizing the study guide, We're going to pull out the really important stuff, the things that'll stick with you.
The stuff that'll make you go, uh-huh, on exam day. Like,
Yeah.
I remember this.
Exactly. We'll dig into real-world case studies, those tricky tech challenges.
And we'll find those little strategic insights that, well, they really separate those certified cloud architects from, well, everyone else.
Oh, yeah. Okay, and speaking of real world, get this. We're going to be using this fictional company called Symbol Direct.
They're a shoe company.
A shoe company, yeah, but with some pretty big dreams.
Big shoes to fill, right?
Exactly. So imagine drone deliveries, but with live video feeds.
Oh, wow, that's next level.
And they want public APIs so all their partners can easily integrate with their systems.
Makes sense, because could he keep everyone in the loop?
And hold on, they also want to integrate with social media, show off that user-generated content.
Ooh, that's always a fun one. Got to be careful with that, though.
Yo, tell me about it. I hear they've had a few close calls.
Like what? What happened?
Almost showed some, let's just say, not safe for work images.
Oh, no.
Yeah.
Social media integration could be a real minefield. Got to watch out for those unexpected surprises.
Yeah, it just goes to show even a simple business goal can lead to some pretty complex technical challenges.
And that's really what this exam is all about, isn't it?
Totally. Understanding those challenges and figuring out how to build secure, scalable, and cost-effective solutions on Google Cloud.
You got to think like a cloud architect. Put that hat on.
Speaking of challenges, Symbol Direct's current tech setup, well, let's just say it's a bit of a mixed bag.
How so? What are they working with?
They're using Kubernetes for some stuff, which is great, but then they've also got these older technologies like MongoDB clusters
Oh, wow. Going old school.
and good old Ubuntu VMs.
The trusty Ubuntu VM never goes out of style.
Right, so you'll really get to put on that cloud architect hat and figure out how to, modernize all of this using Google Cloud.
It's like walking into their tech department on day one. You're leading the cloud transformation.
Exactly. You got to understand their business goals.
Things like scaling for growth, right? Making sure their development is streamlined, and of course, keeping those customers happy.
Oh, absolutely. That customer experience is key.
And then you got to take all that and translate it into actual technical solutions using Google Cloud.
Okay, so let's get specific.
Let's do it.
One of Symbol Direct's big goals is this drone delivery system.
Okay, yeah, the one with the live video feeds we talked about.
Right, that one. And they want public APIs so partners can, hook into their logistics platform.
Smart move.
And, of course, everything has to be, rock solid, Super reliable, super scalable.
So where do we even begin with all of that?
I don't know, it's a lot.
Well, for those live video feeds from the drones, we probably want to look at Google Kubernetes Engine, GKE,
Ah, Kubernetes. Everyone's talking about Kubernetes these days.
right? And GKE, it's Google Cloud's managed Kubernetes service, perfect for running all those, what are they called, containerized workloads.
Containerized workloads, yeah. And you can scale them up or down whenever you need to, right?
Exactly, exactly.
Okay, but I gotta be honest, some of those Kubernetes concepts still kind of trip me up.
Like what? What's got you stumped?
Well, what's the difference between a deployment and a stateful set? And when would I use one versus the other for Symbol Direct's drone delivery thing?
Okay, good question. Think of it this way. A deployment, it's like a blueprint, right? For running identical copies of your application, but they don't need to remember anything between sessions.
So kind of stateless.
Yeah, exactly,
Yeah.
stateless. Good for things like a basic web server.
Okay, that makes sense. So what about stateful set then?
Now, a stateful set, that's designed for applications that need to remember things to maintain state, like databases,
Oh,
or in Symbol Direct's case, that drone video streaming service.
because those drones need to maintain a constant connection, right, to the pilot system or whatever.
Exactly. Even if those pods are moved around in the Kubernetes cluster, those connections got to stay stable.
Oh, I see. So it's like each drone has its own little reserved parking spot, and even if they're shuffled around, the connection stays put.
Perfect analogy. You got it.
Okay, so stateful set, it's all about maintaining state.
Yep, you got it.
Got it. Okay, so we've got our drones streaming video, but how do we manage all the traffic coming in?
Ah, that's where load balancers come in.
Load balancers, right. Those are important.
Super important. They're like the traffic cops of your cloud environment, making sure everything flows smoothly.
Even if there's a sudden surge of users, like everyone wants to watch those drone deliveries at the same time.
Exactly. The load balancer makes sure no single server gets overloaded and crashes the whole party.
Okay, that makes sense.
And then we got to think about cloud build and artifact registry.
Oh, yeah. Those are essential for building and managing those container images, right? For that whole drone delivery system.
Absolutely. Think of cloud build as your automated construction crew. They're assembling those container images from the code and all the other stuff it
The
needs.
dependencies, all that.
Right, all the dependencies. And artifact registry, that's where you store and manage those images, all nice and organized, ready to be deployed to that GKE cluster.
So Cloud Build puts it all together, and then Artifact Registry keeps it safe and sound.
Exactly. Streamlined and secure. Just what we like to see.
Okay, but we're not done yet, right? What about deploying all of this?
Ah, yes. Deployment. We got to talk about Terraform.
Terraform, right. That's all about those repeatable deployments.
And infrastructure as code. Can't forget that.
Yeah, that's important for SimpleDirect. They're growing fast, they need to be able to spin up new infrastructure quickly, and they need it to be consistent.
Exactly. Terraform is like having a set of blueprints that you can use to recreate your entire cloud infrastructure whenever you need to.
No more manual clicking around and hoping you didn't miss a step.
Exactly. It eliminates those human errors, ensures consistency, and makes collaboration a breeze.
Okay, so we have GKE for those containerized workloads, load balancers to manage the traffic, Cloud Build, and Artifact Registry for building and storing those containers.
And Terraform to make those deployments smooth and repeatable.
Wow, that's a lot to think about. But the exam isn't going to just, throw these concepts at you in isolation, right?
No way.
Yeah.
It's all about applying them to real-world scenarios, just like we're doing with SimpleDirect.
Okay, good, because I'm more of a hands-on learner.
Me too. That's why we're taking this approach.
Let's test out those problem-solving skills with a couple of exam-style questions, then.
Hit me with it.
All right, so imagine SimpleDirect's trying to figure out the best storage class for their drone telemetry data.
Okay, go.
They only need to access it every once in a while, so which class would be the most cost-effective?
All right, think of your Google Cloud storage options like a Spectrum. Okay.
Okay, a Spectrum, got it.
On one end, you've got standard storage. It's like a penthouse suite, top-notch performance, but it'll cost you.
Makes sense.
Then on the other end, you've got archive storage, dirt cheap, but accessing it is like, well, good luck.
So slow and painful.
Very slow, very painful. Now, for SimpleDirect's telemetry data, they don't need super fast access, right? So nearline storage, that's the sweet spot.
So nearline is kind of like the middle ground.
Exactly. Good performance, reasonable cost, perfect for data you don't need to access all the time.
Okay, that makes sense.
It's all about picking the right tool for the job. That's a big part of the exam.
Speaking of the right tool, another question that caught my eye was about defining smart KPIs for SimpleDirect's web application. What makes a KPI smart, anyway?
So smart KPIs, they got to be clear, measurable, and relevant to what you're trying to achieve.
Okay, so not just like, we want our website to be fast.
Right. A smart KPI would be more like, we want 85% of web application requests to be successful.
Ah, so it's specific, you can actually measure it, and
Yeah.
it relates directly to, keeping customers happy.
Exactly. It's about taking those vague goals and turning them into concrete targets you can actually track.
I like that. Very practical. Okay, another question that got me thinking was about optimizing those compute engine instances.
Ah, gotta love some cost optimization.
Right, so what happens when SimpleDirect needs more RAM for their VMs?
That's when you bring in the custom machine types.
Custom machine types. Okay.
Think of it like renting a car. If you just need to run errands around town, a compact car will do.
Right, keep it simple.
But if you're going on a road trip with a whole bunch of luggage, you're going to need something bigger.
Okay, I see where you're going with this.
So with custom machine types, SimpleDirect can adjust the size of their virtual machines, so they're not paying for more CPU or RAM than they actually need.
Smart move. And it highlights how important cost optimization is for the exam, too.
Oh, absolutely. It's not just about knowing how to deploy things, it's about deploying them efficiently.
Speaking of efficiency, this next question throws a bit of a networking curveball at us.
Ooh, I love a good curveball. Let's hear it.
All right, so should SimpleDirect use VPC network peering or shared VPC to connect different parts of their infrastructure?
Okay, classic networking question. Got to know your stuff.
Yeah, this one tripped me up a bit.
Well, think of VPC network peering like building bridges between separate islands.
Islands.
Each VPC is like its own little island, and peering lets you connect them securely.
So if Symbol Direct wants to connect to, like, their retail division, which is in a totally separate Google Cloud organization, peering would be the way to go.
Exactly. It's for connecting separate entities.
Okay, that makes sense. What about shared VPC then?
Shared VPC is more like creating a network within a single island.
So all within the same Google Cloud organization.
Yep, exactly. It simplifies management if everything's under the same umbrella.
So if Symbol Direct wants to share resources and networking stuff between different departments within their own organization, shared VPC is the better choice.
You got it.
Okay, it's like choosing between bridges and internal roads
Mhm.
depending on how Symbol Direct wants to structure their network.
Another great analogy. You're on fire today.
Haha, thanks. Okay, one more question before we move on, just to really solidify those Kubernetes concepts.
Bring it on.
Remember how Symbol Direct is starting to containerize more of their applications?
Yeah, they're jumping on the container bandwagon.
Right. So the question is, for their drone delivery service, which relies heavily on those persistent connections, should they use a deployment or a stateful set?
Back to our drone parking analogy. Remember how those persistent connections are like assigned parking spots?
Yeah, those connections need to stay stable even if the CODs are moved around.
Exactly. So for that, you definitely need a stateful set. It makes sure each drone maintains that connection to the pilot system, no matter what.
So stateful sets are like those reserved parking spots, keeping everything organized and connected?
You got it. It's all about choosing the right tool for the job. And the exam will definitely test you on those Kubernetes concepts.
Okay, good to know. I'm starting to feel a lot more comfortable with those Kubernetes terms now.
That's what we like to hear.
So we've got a good handle on designing those cloud solutions, but what about actually managing and provisioning those resources on Google Cloud?
The nitty-gritty details. That's where the real fun begins.
I'm a little nervous about all those VPCs, firewalls, storage options, and CI/CD pipelines. That's coming up next, right?
You bet. We're going to roll up our sleeves and get hands-on with the Google Cloud Platform, using all those tools and services we just talked about to bring Symbol Direct's cloud vision to life.
Can't wait to dive into the details.
Me neither. See you in part 2.
Welcome back to our deep dive into the Google Cloud Professional Cloud Architect Certification Exam.
We're ready to get into the nitty-gritty of managing and provisioning all those Google Cloud resources.
It's like we've got those blueprints for Symbol Direct's cloud infrastructure all drawn up.
Yeah, and now it's time to start, laying the foundation, putting up the walls.
I'm excited, but a little intimidated, to be honest.
Don't worry, we'll take it step by step.
So where do we even begin with all this?
Well, security is always a good place to start, right?
Oh, yeah, especially after Symbol Direct's little social media mishap.
They learned the hard way that security is not something to mess around with.
And the exams can test us on it too, right?
Oh, absolutely. So let's talk about some key concepts.
Hit me with it.
All right, first up, identity and access management. IAM for short.
IAM, right. I've heard of that.
It's like the security guard for your entire Google Cloud project.
So it controls who can access what.
Exactly. Imagine you're setting up access for Symbol Direct's employees.
Okay, I'm imagining it.
You'd use IAM to create roles and permissions based on their, what they need to do their jobs.
So someone in marketing might be able to see social media analytics data, but someone in finance wouldn't.
Precisely. You're giving people just the right level of access they need without compromising security.
Makes sense, need to know basis and all that.
Right. And it goes beyond just individual users, too. Yeah. You can also use IAM to manage those service accounts. Those are like virtual identities for applications and services.
Okay, so like robots with their own logins.
Exactly. Remember Symbol Direct's drone delivery system?
Yeah, those little flying robots.
You'd probably create separate service accounts for each part of that system.
Each part, why?
Well, if one account gets compromised, it limits the damage, right?
Oh, I see. So it's like having security clearances for different parts of the system, adding another layer of protection.
Exactly. It's all about minimizing risk.
Smart. Okay, so IAM is all about controlling who can do what.
Right. Now, to really lock down their infrastructure, we need to talk about virtual private clouds.
VPCs. I think I've heard that term before.
They're basically your own private space within Google Cloud, where you can control all the network traffic, set up firewalls, all that good stuff.
So it's like building a fortress around your data and applications.
Exactly. Remember Symbol Direct's security requirements for their VPC network?
Oh, yeah, they got pretty specific after that social media incident.
No working from home, only authorized access, and really granular visibility into all the network traffic.
Right, they don't want any more surprises.
So how do we actually make that happen?
Yeah, how do we make sure their VPC is Fort Knox level secure?
Well, first up, firewall rules.
Firewall rule, okay.
These are like the gatekeepers of your VPC. They decide who gets in and who gets turned away,
Based on what?
based on things like IP addresses, ports, protocols, all those network details.
So we can set it up so only people from SymbolDirect's offices can access the VPC.
Exactly. That's just one example, though.
What else can we do?
We can use VPC service controls, too.
VPC service controls
It's like drawing a virtual perimeter around your sensitive data, making sure nothing escapes.
and making sure no unauthorized users can get in.
Right. Think of it like a moat around a castle, an extra layer of defense.
I like that analogy. So firewall rules are like the guards at the gate, and VPC service controls are like the moat around the castle.
You got it. But we also need to be able to monitor what's going on inside the VPC.
Yeah, do we have security cameras everywhere?
Not cameras, but we have something even better. VPC flow logs.
Flow logs, okay.
They give you all the details about the traffic moving in and out of your VPC.
Like who's connecting to what and when.
Exactly. It's like having a detailed record of every network interaction.
That's super helpful for security analysis and probably for troubleshooting too, right?
Oh, absolutely. If something weird's happening on the network, these logs can help you figure out what's going on.
Okay, I'm starting to feel a lot better about SymbolDirect's cloud security now.
Good. But we're not done yet. We got to talk about their applications, too.
Right, those applications need to be secure, A&D, they need to handle all that traffic.
Exactly. Remember that secure messaging app example from the study guide?
Yeah, the one with the crazy traffic spikes throughout the day.
Right. They needed something that could scale up and down quickly, and it had to be super secure.
Especially after that social media incident, they're not taking any chances.
So the study material suggests App Engine for this scenario,
App Engine, okay. Remind me what that is again.
like a platform as a service, PaaS for short.
PaaS, right. Got it.
It basically takes care of all the underlying infrastructure stuff for you.
So all the servers, the networking, all that.
Exactly. So SymbolDirect's developers can just focus on building and deploying their app code. No need to worry about all those infrastructure details.
It's like Google Cloud takes care of the plumbing, and SymbolDirect's developers get to focus on the design and functionality.
Exactly. And App Engine's got some great built-in security features.
Oh, like,
Stuff like automatic scaling and support for multiple programming languages, too. It's a pretty sweet deal.
okay, sounds good. But remember, that secure messaging app, it's got two main parts, right? The web app for registration and the chat protocol thing.
Oh, right. Good point. It's not just a simple website.
Exactly. So can App Engine handle both of those?
Well, for the web app, we'd probably use the App Engine standard environment.
Okay, the standard environment. Got it.
It's perfect for handling web requests and, user registrations and stuff.
So that takes care of the front end. What about the back end, those chat servers?
For those, we might want to use Compute Engine.
Compute Engine, that's where we get those virtual machines, right?
Exactly. It gives you more control over those virtual machines running your application.
So more customizable.
Yeah, more customizable, and we can create a managed instance group, a MIG.
A MIG, what's that?
Think of it like a fleet of virtual machines all working together to provide that chat service.
So it's like having a team of synchronized swimmers all working in perfect unison.
Love that analogy. And the best part is you can scale that team up or down depending on how much traffic you're getting.
So if there's a sudden surge of chatty users, we can just add more virtual machines to the MIG.
Exactly. And when things calm down, we can scale back down, save some money on those compute costs.
Smart. That way, we're always ready for anything.
And we need to make sure those chat requests are distributed evenly across all those back-end servers.
Right, we don't want one server getting overloaded while the others are just sitting there.
That's where load balancing comes in again.
Ah, our trusty traffic cop.
In this case, we'd use an external network load balancer. It sits in front of those MIG instances and distributes all those incoming requests, making sure everything runs smoothly.
So we've got App Engine for the front end, MIGs for the back end, and a load balancer to keep everything balanced.
Exactly. It's all starting to come together.
It is. But before we move on, I have a question about those user accounts for the messaging app.
Okay, shoot.
Remember that scenario in the study guide where customers can delete their accounts?
Yeah, the right to be forgotten and all that.
Right. But SymbolDirect also has a 60-day return policy.
Oh, this is tricky. What happens if someone deletes their account and then tries to return something?
Exactly. They need that account info, but the customer wants their data deleted.
Yeah, it's a classic data retention dilemma.
It is. So how do we balance those competing needs?
Well, instead of permanently deleting the data right away, we could just disable the account.
Disable it so it's still there but not active.
Exactly. Then we can export all that account data to cloud storage, Google Cloud's super secure and scalable storage service.
So it's like putting those accounts in a timeout corner. They're still there if we need them, but not causing any trouble.
Perfect analogy. And we can set it up so that data gets automatically deleted after a certain period.
Like 90 days to cover that 60-day return policy?
Exactly. That way, we're respecting the customer's wishes while also meeting those business requirements.
It's a win-win. I'm really starting to see how much thought goes into being a cloud architect.
It's definitely more than just knowing the technical stuff. It's about understanding those business needs and making sure everything works together smoothly.
Speaking of making things work smoothly, let's talk about automation.
Ah, yes, automation. A cloud architect's best friend.
Right. Remember how SimpleDirect's been manually building those new application releases?
Painstaking and time-consuming.
Exactly. They need to automate that process, make it faster and less prone to errors.
And that's where CI/CD pipelines come in.
CI/CD pipelines, right? The study material mentioned those. Can you remind me what those are all about?
Sure. CI/CD stands for continuous integration and continuous delivery, or deployment, depending on how you're setting things up.
So it's like an automated assembly line for your software development process.
Exactly. You're automating all those steps, from building and testing to deploying your code.
No more manual deployments, no more typos causing chaos.
Right. And that automation brings a ton of benefits.
Like what?
Well, it speeds up development, so SimpleDirect can release new features more often.
Okay, that's good for keeping those customers happy.
And it reduces the risk of human error, those typos and misconfigurations that can really mess things up.
Oh, I've definitely been there. Accidentally deleted an entire database once.
Ouch. Yeah, automation can definitely prevent those kinds of disasters.
So, can you walk me through a typical CI/CD pipeline?
Sure. Let's use SimpleDirect's drone delivery app as an example. A developer writes some code for a new feature.
Okay, got it.
First step, they push that code to a source code repository, like cloud source repositories.
That's like the central hub for all their code.
Exactly. Then before we deploy anything, we got to make sure it actually works.
Testing, right? Can't forget about testing.
Exactly. So
Yeah.
we configure the CI/CD pipeline to run a bunch of tests automatically
Every time new code is pushed.
every time. It's like having an automated quality control inspector, making sure everything's up to snuff.
I like that. So if the tests pass, what happens next?
Then we build a Docker container.
Ah, Docker containers, those lightweight, portable packages.
Exactly. We're packaging up that new feature code and all its dependencies into a neat little container.
Okay, so the code's been tested, packaged up. What's next?
We store that container in a container registry, like Artifact Registry.
Artifact registry, right?
Think of it like a library for your containers. You can manage different versions, control access, all that good stuff.
Organized and secure. I like it.
And the final step is deployment. We configure the pipeline to automatically deploy that container to wherever it needs to go.
Could be App Engine, Compute Engine, Kubernetes, even an on-premises server.
Exactly. It's all automated, no manual intervention needed.
That's amazing. So we've got this whole pipeline that takes our code from raw materials to a finished product all automatically.
Exactly. And you can customize it to fit your specific needs, add different stages, tools, notifications, whatever you need.
Okay, so CI/CD pipelines are definitely a game changer, but let's talk about a specific scenario from the study guide.
Okay, which one?
Remember SimpleDirect's legacy application, the one running on those old Ubuntu VMs in their own data center?
Oh yeah, they want to move that to Google Cloud without rewriting the whole thing.
Exactly. So the question is, how do they do that?
Well, the study material outlines a couple of approaches.
Okay, let's hear them.
The simplest option is to just use Compute Engine to deploy those Ubuntu VMs in Google Cloud.
So just lift and shift those VMs as is.
Pretty much. It's straightforward migration, doesn't require a ton of changes to the app code.
Okay, that's option one. What's the other option?
If they want to get a little more cloud native, they could containerize the application and deploy it on Kubernetes Engine.
So package it up in Docker containers and run it on GKE.
Exactly. It's a bit more work up front, but containerization offers a lot of benefits.
Like what?
Improved portability, scalability, resource efficiency, all that good stuff. It's a great way to modernize those legacy apps.
So it's a trade-off. Do we go for the simple lift and shift or invest the effort in containerization?
Exactly. It depends on SimpleDirect's priorities and what they're comfortable with.
Right, and as cloud architects, we'd be there to guide them through that decision.
Absolutely. We'd lay out all the options, explain the pros and cons, and help them make the best choice for their situation.
Okay, I'm feeling a lot more confident about those migration strategies now.
Awesome. But there's one more tool I want to talk about before we move on.
Oh, which one?
Terraform. We touched on it briefly earlier, but it's so important it deserves its own little spotlight.
Terraform, okay, the infrastructure as code tool.
Exactly. It's all about managing your cloud infrastructure using code instead of, clicking around in the console.
And that's a good thing.
Oh, the very good thing. It makes your deployments way more consistent and predictable.
Okay, explain that to me.
Imagine you're setting up that network for SimpleDirect's drone delivery system.
Okay, lots of VPCs, subnets, firewalls, all that fun stuff.
Right. With Terraform, you define all of that in code, so every time you deploy, it's exactly the same.
No more accidentally forgetting to configure a firewall rule.
Exactly. It eliminates those human errors and ensures that everything is set up the way it's supposed to be every single time.
Okay, I'm liking this Terraform thing more and more.
And it makes collaboration way easier, too.
How so?
Well, multiple people can work on the same infrastructure code, just like they collaborate on application code.
So no more emailing config files back and forth and hoping you don't overwrite each other's changes.
Exactly. It's a much smoother and more efficient way to work.
Okay, Terraform is officially on my list of favorite cloud tools now.
It's a good one to have in your arsenal. Now, let's switch gears again and talk about APIs.
APIs, right. Those are important for letting different systems talk to each other.
Exactly. And remember, SimpleDirect wants their partners to be able to place orders programmatically.
So they need APIs, and those APIs need to be well designed.
Absolutely. Well-designed APIs are crucial for scalability, maintainability, security, all those good things.
Okay, so what are some key principles for designing those APIs effectively?
One of the most important ones is loose coupling.
Loose coupling, what's that?
It means that the systems using the API, those clients, they shouldn't need to know too much about how the API works internally.
So it's like a black box. You input the order information, you get a confirmation, and you don't need to know about all the gears turning inside.
Exactly. That makes the API more flexible and easier to maintain.
Okay, that makes sense. What else is important?
Clear and consistent naming conventions are crucial too.
So no more cryptic abbreviations or inconsistent terminology.
Right. The API should use human-readable names that make sense to anyone using it.
So instead of a function called PO, we'd have a function called process order.
Exactly. Much easier to understand and work with.
Makes sense. Anything else?
Documentation. Good documentation is essential.
So developers at SimpleDirect's partners know how to use the API without pulling their hair out.
Exactly. It's like having a user manual for your API guiding those developers through the integration process.
Okay, I'm starting to appreciate the art of API design. It's more than just writing code. It's about creating a good user experience for other developers.
Exactly. And well-designed APIs are essential for building those robust and scalable cloud solutions.
Okay, so we've got our APIs under control. What about those compute engine instances?
Ah, yes. Those virtual machines, we need to make sure those are locked down tight.
Right, security is always a top priority.
Absolutely.
Okay.
So how do we secure those VMs? Well, it's kind of like securing your house.
Oh, okay, I'm intrigued. Tell me more.
You wouldn't leave your doors and windows wide open, right?
Definitely not.
So we need to make sure those VMs have the proper locks and alarms in place.
Okay, so what are some of the locks we can use in our cloud environment?
One of the first things you do is set up network tags.
Network tag.
They're like labels for your VMs, and they allow you to control traffic flow based on those labels.
So I could create a tag for like drone control and another tag for drone telemetry, and then set up firewall rules so only VMs with those tags can talk to each other.
Exactly. It's like creating those secure zones within your network.
Okay, so network tags are like security clearances for our VMs.
Right. And we can also enable Secure Boot and VTPM on those EMs.
Secure boot and VTPM, okay. Those sound important, but what do they actually do?
Secure Boot makes sure that only trusted operating systems and bootloaders can run on the VM.
So it's like having a bouncer at the door, making sure only authorized software gets in.
Exactly. And VTPM provides those hardware-level security features, protecting against things like malicious software and tampering.
So it's like adding tamper-proof seals to our VMs, making sure nobody's messing with them.
You got it. By combining these techniques, we can create a really solid security posture for those compute engine instances.
Okay, I'm feeling good about those VM security measures.
Good. Now let's talk about Kubernetes again.
Oh, Kubernetes, our favorite container orchestration system.
As a powerful tool, but it can be a bit complex.
It can. And remember how SimpleDirect's been using Kubernetes to run their front-end web application?
Yeah, they're loving all those containers.
Right. So the question is, how do they scale those pods efficiently to handle all those users?
Ooh.
Scaling Kubernetes, a classic cloud challenge. But don't worry, Kubernetes is designed for this.
So how do we do it?
Well, one of the most useful tools is the kubectl autoscale command.
Kubectl autoscale.
Okay, it lets you set up automatic scaling rules for your deployments.
Deployments, right. Those are like the blueprints for our applications in Kubernetes.
Exactly. So imagine SimpleDirect's web application is running on, let's say, 3 pods.
Okay, 3 pods to handle all those shoe shoppers.
Now, let's say they have a big sale, and suddenly there are tons of users trying to access the site.
Oh no, the website's going to crash.
Not if we have auto-scaling set up. We can tell Kubernetes to automatically create more pods if the CPU usage on those existing pods gets too high.
So it's like having those elastic servers expanding and contracting based on demand.
Exactly. That way, the website can handle those traffic spikes without breaking a sweat.
And when things calm down, it scales back down to save money.
Exactly. It's all about finding that balance between performance and cost-effectiveness. Makes sense. But we also need to make sure all those requests are distributed evenly across those scaled-up pods, right?
Ah, good point. That's where load balancing comes in again.
Load balancing, always saving the day.
Think of it like those cashiers at a busy store.
Yeah.
The load balancer is the person directing customers to the cashier with the shortest line, making sure no one gets overloaded.
Okay, so even if we have dozens of pods running, the load balancer makes sure they all get a fair share of the traffic.
Exactly. It's crucial for keeping those response times low and those users happy.
Happy users, happy life. That's what I always say.
Couldn't agree more. Now let's look at one more challenge from the study material, something a little more advanced.
Okay, bring it on.
Remember that load balancing setup we talked about earlier with multiple backends in different regions for that messaging app?
Yeah, that was a pretty complex setup.
Well, now SimpleDirect wants to get even fancier.
Oh no, what are they thinking now?
They want to direct traffic based on the user's location, AND, the specific URL they're trying to access.
So someone in Europe gets sent to the European backend, but they also need to be sent to the right backend based on what they're trying to do on the website.
Exactly. It's like combining geographical routing with URL-based routing.
That sounds complicated. Can Google Cloud even handle that?
Oh, absolutely. We can use a global HTTPS load balancer for the geographical routing.
Okay, so that takes care of sending users to the closest backend.
Right. And then we use URL maps to handle the rest.
URL maps. Okay, what are those?
They're basically sets of rules that tell the load balancer which backend to use based on the URL.
So if you're trying to access the registration page, you go to one backend, but if you're trying to connect to the chat server, you go to a different backend.
Exactly. It's like having a traffic cop directing each request to the right destination.
This is amazing. We're really getting into the fine-grained control of traffic flow now.
And that's what it's all about, understanding these complex concepts and applying them to real-world scenarios like a true cloud architect.
Okay, I'm ready for the next challenge. Let's move on to the final section.
Let's do it. We're almost there.
Welcome back to our deep dive. We've designed solutions, tackled deployments, and even managed all those Google Cloud resources.
It's like we've built this incredible machine for SimpleDirect.
Yeah, a well-oiled cloud machine.
But now we got to make sure it runs smoothly, efficiently.
And that it can handle anything, any challenges that come up.
Exactly. We're talking analysis, optimization, long-term reliability, the whole package.
It's like we're taking this machine for a test drive, see how it performs on the open road.
And speaking of performance, we got to make sure we're not burning through cash like it's going out of style.
Right, cost management. SimpleDirect's learned their lesson about overspending.
It's a critical skill for any cloud architect. Got to keep those costs in check.
The exam's going to ask about that too, right?
Oh, you bet. Luckily, Google Cloud gives us a ton of tools for managing costs.
Okay, lay those tools on me. I'm ready to become a cloud cost ninja.
All right, well, first up, we've got our old friend IAM.
IAM. Again, I thought that was just for security.
It's for security NED cost management.
Oh, right. Because we can use it to control who has access to billing information and stuff.
Exactly. You can assign specific roles related to cost management.
So it's like appointing a CFO for SimpleDirect's cloud journey.
Exactly. Got to keep those finances in order. Another key tool is setting a project budget.
Okay, a budget makes sense.
It's like setting a spending limit. And you can even set up alerts so you know if you're getting close to that limit.
So no more surprise bills at the end of the month.
Exactly. And to avoid accidentally creating a ton of resources, we can use resource quotas.
Resource quotas, what are those?
They let you set limits on how many of a specific resource you can create within a project.
So like we could say you can only have a maximum of 10 virtual machines for this project.
Exactly. It's like putting guardrails in place.
Yeah.
Preventing any accidental overspending.
Okay, that's a relief. No more accidentally deploying an entire data center.
Exactly.
Yeah.
With those tools in place, SimpleDirect's cloud finances will be in tip-top shape.
All right, so we've got our financial house in order. What's next on our optimization checklist?
Let's talk about streamlining development workflows.
Ah, yes, making those developers happy.
Remember how SimpleDirect's been manually deploying all those containers for their drone delivery project?
Yeah, it's been a bit of a pain. Lots of manual steps, lots of potential for errors.
Exactly. So we got to bring in some automation.
Automation is always a good thing.
It is. And for this, Cloud Build is our best friend.
Cloud Build. Okay, remind me what that does again.
It's Google Cloud's managed build service. It automates all those build and deployment processes.
So like a robot that takes our code and turns it into a working application.
Pretty much. A developer pushes code to a repository.
Cloud source repositories, right?
Right. And Cloud Build takes over from there. It compiles code, runs tests, builds Docker containers, pushes them to Artifact Registry, even deploys them to a Kubernetes cluster.
Wow, it does all that. That's impressive.
It's a powerful tool and integrates with all those other Google Cloud services seamlessly.
So it's like having a whole team of automated helpers working behind the scenes.
Exactly. And because it's all automated, it's way faster, way more reliable, and way less prone to human error.
Okay, Cloud Build's definitely going on my list of favorite cloud tools.
That's a good one. Now let's talk about another crucial aspect of running applications in the cloud: durability.
Durability, right? We got to make sure those applications can withstand a few bumps in the road.
Exactly. Whether it's a server crashing, a network outage, even an entire data center going offline, we got to be prepared.
So how do we achieve that legendary cloud durability?
Well, managed instance groups, MIGs, they're a great place to start.
MIGs, didn't we talk about those for scalability?
We did,
Uh-huh.
but they're also great for durability.
Okay, how so?
Remember, a MIG lets you manage a bunch of identical virtual machines, right?
Yeah, like a fleet of little worker bees.
Exactly. Now, if you create a regional MIG, those VMs are spread across multiple zones within that region.
So if one zone goes down, the other zones can pick up the slack.
Exactly. It's like having a built-in safety net.
And we can configure health checks too, right? To make sure those VMs are actually working properly.
Exactly. The MIG will automatically replace any unhealthy VMs with healthy ones, so there's no downtime.
It's like having a self-healing system.
Exactly. But even with all that, we still need to plan for those bigger disaster scenarios, like a whole region going offline.
Disaster recovery, right? That's when we need to pull out the big guns.
Exactly. And when we're planning for disaster recovery, there are two key metrics we need to define: RTO and RPO.
RTO and RPO, I remember those acronyms, but what do they actually mean again?
RTO, that's Recovery Time Objective, it's the maximum amount of time you're willing to have your service down after a disaster.
So if SimpleDirect's drone delivery service goes down, their RTO might be like 4 hours, meaning they want to have it back up and running within 4 hours.
Exactly. And then you have RPO, Recovery Point Objective, that's the maximum amount of data you're willing to lose.
So if their RPO is 1 hour, they're okay with losing up to 1 hour's worth of data.
Right. The specific RTO and RPO values will depend on how critical the application is and what the business needs.
Okay, that makes sense. So how do we actually achieve those RTO and RPO targets?
Well, there are a lot of different strategies, but one common one is to use a multi-region deployment.
So deploying the application in multiple regions.
Exactly. That way, if one region goes down, traffic can be automatically routed to another region, and there's no downtime.
It's like having a backup data center, always ready to take over.
And we need to think about data replication, too.
Right. Got to protect that precious data.
For their MySQL database, they could use Cloud SQL with high availability enabled.
Cloud SQL, that's Google's managed database service, right?
Right. It automatically creates a standby instance in the same region, so if the primary instance fails, the standby can take over.
Okay, that's for handling failures within a region. What about those regional outages?
Well, they could also set up a cross-region replica of their database.
So like a mirrored copy of their database in another part of the world.
Exactly. That way, if a whole region goes down, they still have a copy of their data that they can use.
Okay, disaster recovery. Check. We've got those multi-region deployments and data replication strategies all figured out.
We're on a roll. Now let's shift our focus back to day-to-day operations.
Okay, what do we need to cover there?
Remember how SimpleDirect uses that special service for their on-call rotation and alerting?
Yeah, the one they've had for years.
They want to integrate that with their Google Cloud environment.
Ah, right. Got to connect those systems so everything works smoothly.
Exactly. And luckily, Google Cloud's got some great tools for that.
Like what?
Well, in this case, we'd probably use a combination of VPC firewall rules, PubSub, and Cloud Functions.
Okay, I'm familiar with VPC firewall rules, but PubSub and Cloud Functions, those are new to me.
All right, well, think of PubSub as a messaging service. It lets different parts of your cloud environment talk to each other.
So it's like a chat room for cloud services.
Pretty much. Now, imagine you have an uptime check running for SimpleDirect's website.
Okay, so it's constantly checking to make sure the website's up and running.
Exactly. Now, if that uptime check detects a problem, it needs a way to tell someone, right?
Right, someone needs to know so they can fix it.
And that's where PubSub comes in. The uptime check can publish a message to a PubSub topic saying, hey, the website's down.
Okay, so it's like posting a message on a bulletin board.
Exactly. And then we can use a Cloud Function to listen for those messages.
Cloud Functions, those are those serverless functions, right?
So we create a Cloud Function that's triggered by messages on that specific PubSub topic.
And when it sees that website down message, it can do something about it.
Exactly. It could send a notification to SimpleDirect's on-call service, triggering their internal alerting workflow.
It's like a chain reaction of notifications, making sure everyone's in the loop.
Exactly. And it all happens automatically thanks to the power of serverless.
Okay, I'm starting to see how powerful these integration patterns can be.
It's all about connecting the dots, making sure those different systems can talk to each other seamlessly.
We've covered so much ground in this deep dive, from cost management and automation to disaster recovery and integration.
It's been quite a journey. But before we wrap up, there's one more challenge I want to address.
Oh, what's that?
Remember how SimpleDirect's had some trouble with those new software releases for their drone delivery service?
Yeah, a few deployments haven't gone as smoothly as they'd hoped.
Exactly. They're looking for ways to prevent those issues from happening again.
Who isn't? Smooth deployments are a developer's dream.
The study material suggests adopting an agile development process.
Agile development, right. That's one of those buzzwords everyone throws around.
It is a bit of a buzzword, but it's also a really valuable set of principles and practices.
Okay, so what does agile actually mean in practice?
It's all about being flexible, collaborative, and continuously improving.
So not just moving fast and breaking things.
No, not at all. Agile methodologies like Scrum and Kanban, they promote iterative development, frequent releases, and close collaboration between developers and stakeholders.
So instead of releasing big updates every few months, they could break down their work into smaller chunks and release more frequently.
Exactly. That way they get feedback faster, they can adapt to changes more easily, and the whole deployment process becomes more stable.
It's like taking smaller steps, so you're less likely to trip and fall.
Exactly. And to make those deployments even smoother, they could use canary deployments.
Canary deployments, like the bird.
Yep, just like that.
Yeah.
You release the new version to a small group of users first, like a test run.
So if everything goes smoothly, you release it to everyone else, but if there are problems, you can quickly roll back.
Exactly. It minimizes the impact of any issues and keeps those users happy.
Okay, I'm convinced. Agile development and canary deployments, those are definitely worth exploring.
They are. And remember, this deep dive has been about more than just passing an exam.
It has. I feel like I've learned so much about what it actually takes to be a cloud architect.
That's what we were hoping for. It's about having the knowledge, the skills, and the mindset to build those amazing cloud solutions.
Well said. I'm feeling inspired and ready to tackle any cloud challenge that comes my way.
That's the spirit. And remember, the cloud's always changing, so never stop learning.
Always be learning. I like that.
Stay curious, experiment, explore, and you'll be well on your way to cloud architect greatness.
Great advice. And to all our listeners out there, best of luck on your cloud journey.
Happy clouding.